Okay, so today, if you look at the drill here, it's asking us to find the missing sides of our triangle. So you'll notice that neither one of our triangles is a right triangle, which means that we can't use right triangle trig. So that means we're going to have to use either the law of sines or the law of cosines to find our missing sides. So what we might want to consider first is when do we use each one. So the first thing we want to look at is, well, if we have the law of sines, we're going to use the law of sines if we have angle, side, angle, if we have angle, angle, side, or if we have side, side, angle. We're going to use the law of cosines if we have side, 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 or if we have side, angle, side. So when you look at this number one triangle, what do we have? Well, when I look at what we have here, I see that we have an angle, we have a second angle, and we have a side, which means we have angle, angle, side. So we're going to use the law of sines for that first triangle. Now, if you're like me, you kind of like to plan ahead. So when I look over here, I see I have a side, I have an angle, and I have a second side. So I'm going to use the law of cosines on that one. And so here we go. So let's go back to our pen and let's write the law of sines. So the law of sines, so since this is side H, this is probably capital H. This is side K, so that's capital K. And then this is 14, so let's just call that angle F. We'll let that side be F. So we need to find angle K. We know that the angles add up to 180, so we're going to do 40 plus 79, which is 119, and we're going to subtract that from 180, and that's going to be, I believe, 61. So that's going to tell us that angle K is 61 degrees. Beautiful. So now we can set about using our law of sines. So our law of sines, if you recall, is the sine of an angle, and this side we happen to know angle F and side F. So we're going to use F and F. And then we're going to find, let's find side H first. So we're going to do the sine of H divided by a little h. So we type that in our calculator. Well, we set up our proportion first. The sine of 40 degrees divided by 14 is equal to the sine of 79 degrees divided by h, and we cross multiply. So h times the sine of 40 degrees equals 14 times the sine of 79 degrees. So that means that h is going to be 14 sine 79 divided by the sine of 40. And then you type that in your calculator, and we're going to round our answer to the nearest tenth. So we have 14 sine 79, close the parentheses, divided by the sine of 40. And I got 21.3799, so I got 21.4. So that's h. So now I have to do the same thing to find k. So to find side k, I'm going to do the same thing. I have the sine of f divided by side f equals the sine of k divided by sine k. Look, it says sync. So the sine of 40 divided by 14 equals the sine of 61 divided by k. Cross multiply. And then you just type that in your calculator. And round to the nearest tenth, and I got 19.049, so that's going to be 19. And then for our law of cosines over there, well, our law of cosines, we're looking for h, so this is angle h. So h squared equals whatever these two sides are. We could call them A and B. You can name them whatever you want. A squared plus B squared minus 2AB cosine C. But in this case, it's h. So A is 40, so 40 squared plus 52 squared minus 2 times 40 times 52 times the cosine of 34. And again, everything on the right-hand side is a number, so you can type all of that into your calculator. And we find that h squared is 855.0.369. And we don't round till the very end, so we're going to take the square root of that. And remember, on your calculator, you can just do the square root of the answer, which is second the negative sign. And so we find that h is 29.24, so h would be 29. Okay? So that's the first thing we want to work on today, is recognizing when to use point 2. When to use each of our laws. So that's when you want to use each of your laws. We're going to do some practice with that at the end of class. What we're going to do now is we're going to derive and use a formula to calculate the area of non-right triangles. So the first thing we want to do is, when we find the area of a triangle is 1/2 the base times the height. Okay? So if I were to find the area of this triangle, it would be 1/2 the base, which is 8, times the height, which is 3. So my area would be 12. Here, my area would be 1/2 of 15 times 12, which would be 90. And that's square meters, and this is square centimeters. Now the problem comes in here when we have a triangle like this. I'm going to tell you, for whatever reason, I have cut this off. So that's 2 centimeters, and this is 12 centimeters. So what you would have to do here is you could find the area of 2 different triangles and add them together. Or you could recognize, no, we have to do that. So we have to do 1/2 the base times the height. So our base here is 14. So we'd have 1/2 our base, which is 14, times our height, which is 4. So that's going to be 28 centimeters squared. Okay, all we did there was calculate the area. Now what happens here? Well, what happens here is we don't know the height, but we do know our base is 52. So if we were to find the height of this triangle, right, this side is the opposite. This is our hypotenuse. So when we do that, we would be doing the sine of 34 equals the opposite divided by our hypotenuse, which is 40. So we'd have 40 times the sine of 34. So that's what O would equal. and then we take 1/2 of that times the base. Well, guys, we could just go straight to that formula. Anytime we have to find the area of a non-right triangle, we're going to do 1/2 the side times the other side times the sine of the angle in between. So to find this, all you have to do is type in your calculator 1/2 of A, which is 52, times B, which is 40, times the sine of the angle in between, which is, for us, 34. So we type that in our calculator. And I got 581.56, so I'm going to call that 581.6. And that would be units squared. And that's it. There's a couple of more practice problems here we can do, but that's pretty much it.